In this video, we're going to talk about .NET Core dependency injection and how the lifetimes affect service creation and disposal. We will cover how ASP.NET Core creates these services and some common use cases. I will also provide some guidance as to when to use each. Hey, my name is Justin Colston with SparkPoint University. If you're new here, please don't forget to subscribe and be sure to like this video. Let's get right into the code. In this way, I want to show how lifetime works in terms of dependency injection. So if you don't know what dependency injection is, I'll try to give you a quick brief on it. Dependency injection is a way to create services, keep them decoupled, and have them wired up when they're needed at runtime. For instance, let me show you this transient service dependency. I created this dependency, and it does nothing. There's a constructor, and it's going to write out basically that it was created on the console. Then when it gets disposed, based on iDisposable, it will then show that it was disposed in the console. Now this is a dependency. But what about a host or a service, right? So I have this transient service host, which needs that dependency, and it's getting injected into the constructor. Now I'm not doing anything with this. There's no methods to call. I'm just injecting it so that it will be created and destroyed depending on the lifetime. And with these hosts, of course, I'm creating and destroying these as well the same way. And you'll see those in the console. There are three sets. I have Transient, Singleton, and Scoped. Let's hit play first. That'll probably be the easiest way to explain how each one of these different lifetimes work. And watch how these things are created. So if I go back to program, I just want you to see that in this, I'm creating my host. It's configuring services. And down here at the bottom, you can see I configured these services with Transient lifetimes, Scoped lifetimes, and Singletons. And they're in the name, so you will see that when I hit play. Let's go ahead and do that. Okay, so let's take a quick look at what happened here. So I called the transient services, and you see transient service dependency was created, then the host 1 was created, then another dependency was created, then host 2 was created, and then host 2 was cleaned up, dependency was cleaned up, host 1 was cleaned up, and then another dependency was cleaned up. So you can see in this case, Transient was created twice. This dependency was created twice, once for host 1 and once for host 2. Now, let's go down to, we're going to skip Scope for a minute. We're going to go down to Singleton. So in the Singleton case, the dependency was created, then host 1 was created, then host 2 was created. So you don't see any dispose methods being called. That's because it's created for the lifetime of the host, the iHost. It's created for that full lifetime. Now, when that gets disposed, when that gets killed, then they will be cleaned up. And we'll see that here in a second. But then you have scoped lifetime up here. So you see that dependency was created, host 1 was created, host 2 was created, then host 2 was disposed, host 1 was disposed, and then finally the dependency was disposed. Now, unlike the transient, it only created one dependency, and unlike Singleton, it actually did get disposed. But these look very similar. You can see how scope looks almost the same at the top here. So you can see that it was dependency host 1, 2, and then Singleton dependency host 1, 2. But the only difference here is that Singletons did not get disposed yet, but the scopes one did. So let's hit Control C, and you'll see now that host 2 gets disposed, host 1 gets disposed, and dependency gets disposed. So transient lifetimes will create a new service dependency every time a request is made to it by another service. So host 1 requested that dependency, it created the service. Host 2 requested that dependency, so it created another service. In Singletons, only a single instance is created of the dependency. So host 1 requested it, well, it's creating one, right? Then host 2 requested it, well, it's going to go get the one that's already been created. And if there was a third one or a fourth one or a fifth one, it would go get it. Now, scoped is only for requests. In a web application, a request comes through from the outside world, right? So you have an API and you're going to be creating products. Okay, so you say create products and you send it through Postman and it goes and hits your API. At that moment, a new scope is created in ASP.NET Core. And when that scope is created, any scope dependencies, when requested by a service, will then be created. Now, if you have multiple services that are using that same dependency, it will reuse it throughout the lifetime of that scope. But let's just say we had 2 requests come in at the same time. In that case, 2 dependencies would be created, one for each scope, one for each request. So you have a unique dependency for each request that comes through. That's what scoped lifetime is, but it acts like a singleton during that request. But once that request goes back and you create a response and it ends up back at the user's hands, at that moment is when the disposal occurs and those dependencies are destroyed and not seen again. And then when the next request comes in, it recreates it and then disposes it again at the end. So scoped is from the time a request comes in and a service is created to the time the response goes out and then the service is disposed. It acts like a singleton during the request. So let's close this down and let's take a quick look then at some different nuances here. So like I said, we create a service, scope, singleton. Okay, that's fine. In ASP.NET Core, this scope is created for you. You don't see it, but every request that comes in, this scope is created, and this provider, so to speak, this scope service provider is then provided to you to be able to pull those dependencies. So what's important about that is that if you're not using .NET Core, or sorry, ASP.NET Core, and you're using a console app like I have here, if I was to get rid of this scope altogether and just call provider, when you create a scope dependency or you try to get back a scope dependency, it will act like a singleton and it will only get destroyed when the host is disposed. You got to know and you got to remember that this create scope is what allows for a scope dependency to work. Otherwise, it's a singleton. Whereas singletons in this case, even though it does create a scope, will live for the lifetime of the application running. And transients, even though the scope is created, these will die at the end of that scope each time. So the scope is what really does the disposal for you, not when it's dereferenced. It's not some magical thing that happens. No, when scope gets called dispose on it, it then goes and does this backwards algorithm where it goes to the last one that was created, destroys it, and then goes back up the stack and gets rid of all of them. And that includes transients and scoped, but not singletons. So keep that in mind that if you're using this outside of ASP.NET Core, you really need to create these scopes yourself. So that way you can control the lifetimes. But .NET Core, ASP.NET Core, you don't have to worry about that. There's another nuance here that we need to try though, because I want to make sure that it's very clear how this works. So I add a transient, okay, and we have 3 transients here. So when we go out of the scope, these 3 get killed, they get disposed. But what happens if I turn these into, let's say, singletons? What happens? So I will have some singletons here. How I suspect this would work, well, I have a transient here, so this transient is going to get created twice, and at the end of the scope, it'll get killed. Okay, but I have 2 singletons, but they'll survive on, right? They'll live on. Okay, well, let's hit play and see what happens to these transients. Okay. So unlike what we had before, you'll see transient service dependencies created, host 1's created, dependency created, host 2 created. And these are the same because I didn't change these. But you'll notice there's no dispose in here anymore. Well, that's not good. Let's hit Control C. Ah, here they are. Singleton, singleton, singleton disposed, but then the transient host 2 gets disposed, then the dependency gets disposed, then host 1, then dependency. Why did that happen? Well, that happened because singletons, again, are only created once. And when that happens, the library is smart enough to know that it's dependent on transient scopes. And because of that lifetime dependency, it knows that, hey, look, the singleton's still alive. I can't kill the transient scope. I need to hold on to it because it still needs it. If I dispose it too early, then that service might blow up. So I'm going to hold on to it, and it basically turns that transient service into a singleton, in a sense. It doesn't technically turn into a singleton. It can't be reused by other services. It'll create it only once, but it won't ever be disposed until the end of the application. So that's kind of an anti-pattern you want to avoid. This is what sometimes they'll call a captive dependency, meaning it can't do anything, right? It's going to stay kind of with this, and it doesn't really get destroyed when you expect it to be destroyed. So when you create services, and you create services that are dependent on other services, you need to make sure that your scoping is correct and that you know when things will be destroyed, especially if you need to worry about that disposal. A lot of times in CRUD applications, we don't necessarily care about disposal, but there may be some use cases. So let's go ahead and talk about some use cases for these different types of situations. For singletons. Singletons are my go-to lifetime if I can make it happen. There's a couple reasons why I like singleton. One is it only creates one service, and I can rely on that service to be there, and I'm not worried about memory issues because I only have one of them. If I have 1,000 calls hitting my service in an hour, I don't have to worry about it because there's only one service being created. And I recommend that you design your services to use singletons almost entirely. If you can make it happen with a singleton, use a singleton. However, it's not always possible. So a use case for using scoped is for cases like user management. You want to make sure there's no state inside of your class. But let's just say we create a service, and we'll go ahead and create one real quick, something very simple. I'm going to create a singleton service that is used for repository work, right? So we're going to say this is the user repository. in this user repository, I'm just gonna make it real simple. I'm gonna say create user, string name. So here I have a user repository. In this case, I'm just gonna have a method that creates a user, and inside of that method, it's gonna create a SQL connection, it's gonna run a command and dispose of the connection. This is a perfect use case for a singleton. It does not need to be scoped. Instead, it can be reused across the board. And the reason it can be reused is because there's no state inside the class. Let's talk about another instance. Let's go to, instead, user preferences service. So let's create a user preferences service. Now in this case, I'm going to maybe save preferences. But what if in the process I am injecting a user? And I'm going to create my SQL connection, maybe run a command with username, and then of course dispose of connection. In this case, we need to use either transient or scope services. Since when you call an API, a lot of times you may have an authorization header that will tell you the user that's actually accessing your service. You may be able to inject this username when the service is created as a scoped lifetime. Because you want to make sure it's scoped, because that user will be, it's the same user for the request and the response, like it's not changing midway through the request, but there's state inside this class. And when there's state inside the class, it's highly important that this has become scoped, because you do not want to create an issue with singletons. You can't share the state. There's no way to do it. Well, there is ways to do it, but it'd be very complicated. So using scoped here allows you to create one service per user for that request. And we can inject this. This is one case, probably not the best case, but typically, for a request, usually it's a user type service that ends up being shared or scoped. The next one, transient, is a little bit harder. I actually don't find a lot of use cases for transient. However, I will say that probably the best use case is when either one of two things happens. One is you want the most recent information from, let's say, a file, right? So every time the service is being created, it's going to maybe have it'll look it up another time. Like it might look up a file and load it up. Although that doesn't seem like the most effective way to do it. Yeah, maybe you could do it that way. Another way, which I don't necessarily recommend, but I was trying to think of a use case for this, is maybe if you want to use the dispose routine for something practical, right? So let's say that you want to have a SQL class, SQL manager class, and it will have maybe a SQL manager. It'll inject string connection string into here, and maybe there's a bunch of calls. So let's just say there's a bunch of SQL calls that can be made. And then at the end, maybe you have a dispose, right? So maybe it implements dispose, and in this case, it's going to dispose of a connection. So maybe you create the connection, at some point in these methods you create, but you don't want to dispose it right away. Maybe you want to leave it open for some reason, for some performance reason, you leave it open. Then you dispose it at the end. I actually don't find Transient very useful for ASP.NET Core. Instead, I find the most useful ones to be Singletons, which should be 90% of what you have, and then maybe some scoped ones here and there that you may need. If you design your services right, you don't have to have really any state running through your services. And the more state you avoid in your classes, the easier it is to reason about and know that these are just functions and groupings of functions that make it simple. Instead, state should be stored in different types of mechanisms. You may have state stored in a database, so you go pull it. But if you want to cache it, then find ways to cache it. You want to avoid it. And so I would move up the stack and do everything possible to use singletons. And if singleton's not possible, use scoped. And if scope's not possible, then last ditch effort, use transient. So go in that order. Try to make it, work it in that order. Try to make a service a singleton first, then try to make it scoped. And if that still doesn't work, make it a transient. And this really only applies to ASP.NET Core. When you're working in console apps or other like Windows Forms apps, you don't really have scoped anymore. Really, it's just singletons and transients. And I would encourage you to use singletons over transients even in those cases. Hope this video was helpful. If you have any suggestions for new videos in the future, please reach out. Please don't forget to subscribe and like this video. See you next time.